now you have $4,200 and $4,270. That's how much the first one's worth, period. Now then, the second one is done the same way. It goes forward 4 years. It's worth $874. The answer should be the sum of these last two numbers. Looks like about $5,100. And that is what we get, $51,4502. Now for continuous compounding. Continuous compounding, he does not give answers in the book, does not give tables for continuous compounding. We're going to have to be using the equations. We can still write it in economics notation, but to get that factor, we're going to have e to the Rn. For example, how much would $20,000 invested today give you at a nominal interest rate of 6%, but we're going to compound continuously for 7 years. The interest rate is no longer labeled I in these equations. He calls it R because it's the nominal rate to show continuous compounding. He's trying to indicate that's not just the plain old 6% number. Something special is going on here, namely continuous compounding. So you've been asked to find the future value of that cash flow. You were told you would invest $20,000 right now. It collects this kind of interest, e to the Rn. That's R is the rate, and N is the number of years, and therefore you get back from the bank $20,000 times that E value times, what was that E? 2.7 something, don't remember, don't see it. Whatever E is, kick it on your calculator, raised to the 0.06 times 7 gives you $30,439 is how much this is worth in the future. Now then, find the present value that you need to invest to yield a given future value. Since I already worked it out, I was loath to not use it again, so I said, well, how much money would you have to invest today to get $30,493 under continuous compounding for 7 years if the nominal interest rate was 6%? Well, obviously we ought to get $20,000, and we do. The present value is equal to F times P over F. There's R% in years. You do it by E to the minus Rn, in case that's a little hard to read. E to the minus Rn is $30,439.23 raised to the E, multiplied times E raised to the minus Rn. There's the minus 0.06, there's 7, is $20,000, and that's as it ought to be. Alright, now then, find the future value of a series of 7 uniform deposits of 200 each at the end of years 1 through 7. That's standard form because he's putting his annuity in the right time position. If the bank is willing to pay you 6% annual nominal interest rate, but he's willing to compound it continuously. You'll find that equation in the book also for F. F is equal to, in our notation, would be F over A, R% N. But the equation for it is E to the Rn minus 1 divided by E to the R minus 1. Get that right out of the table, right out of your reference handbook on page 73. It's equal to $200. You multiply E to the 0.06 times 7, subtract 1 from it, divide by E to the R value is, this notice is not multiplied times N, and subtract 1 from it, and you get that you would have to invest $1,688.20. Now that's how much you'd be able to take out. If you were willing to put in $200 each year, then you could take out $1,688 at the end of that 7-year period. Alright, now that may not cover all of the ones in the book. I think I quit. That's F over A. There's a couple more there listed in the book, a couple of more continuous compounding things, but they all work exactly the same. So that's all of the ones that I worked. Now, the next thing in the reference manual is book value. The book value of something is how much it's worth at the end of a year, at the end of 2 years, at the end of 3 years, at the end of some number of years. And the book value is also equal to what did you pay for it today? Well, that's its book value today. At the end of a year, it probably is worn out to some extent and has depreciated in value. Since it has depreciated in value, Uncle Sam will let you admit that and let you say its book value is now diminished, and therefore you have in effect spent some money on that item in order to make some money and take it off your taxes to some extent. Now, the book value at any given time will be the initial cost minus the depreciation that you took for this year. The book value for 2 years down the road is the initial value that you took, that it cost you, minus the depreciation you took from last year, minus the depreciation you feel is appropriate to take this year. And so on until you get up to the present time. Each time you take off some depreciation, then the book value is diminished by that quantity in total until you end up with the salvage value. Now, there are several ways to compute that the government permits you to compute depreciation, or how much wear and tear you have on your machines and your computers. One of the most popular one is known as the straight line depreciation method. This equation is listed in the book. The depreciation that you can take in any given year is equal to the initial cost minus the salvage value that you expect to be able to sell the thing for when it's of no longer really use to you, and that would be in the nth year, divided by how many years you use the machine. So, say that you purchased a $30,000 machine, you're going to make income with it. Obviously, if you don't intend to make income with it, Uncle Sam's not going to let you depreciate it or write it off. You think the machine will be useful for 7 years, well, you'll get rid of it. Also, you think its salvage value at the end of 7 years is $2,500. Then straight line depreciation, the amount of depreciation Uncle Sam will let you extract off of your books each year is the initial cost minus, you say you're going to be able to get $2,500 back for it at the end of the period, divided by 7 equal increments, means that he'll let you depreciate the value of that item by $3,928 each year. Now, at the end of 7 years, if you sell the thing for $6,000, then Uncle Sam's going to say, whoa, you didn't quite hit that salvage value. And you say, well, yeah, it was worth a little more than I thought. Then you'd have to pay ordinary income on the difference between that $2,500 and the $6,000 you paid for it, because you've been depreciating that amount. So, here would be the book value. At the end of the first year, at the end of the year, at the end of the day you bought it, you don't get to depreciate it, and it has a book value of $30,000. At the end of the first year, it's got wear and tear of a year on it. You can depreciate $3,928, and therefore it leaves you a remaining book value of $26,071, and so on until you get down to the end, and you ought to come out with a salvage value pretty close, $2,500.